We've reached the 8th and final part of the course on key principles of brain health, focusing on everyday problems like anxiety, insomnia, fatigue and brain fog. And we're looking at how these problems can be underpinned by imbalances or non-optimal functioning in body systems. I've been describing the most common forms of imbalance and how functional testing gives you the basis for making personalised and targeted interventions that are going to be the most effective in creating change. So these are the most relevant body systems for our purposes, the systems that the brain depends on to meet its needs, and places where non-optimal functioning is going to have an impact on the brain. And in this part, we're looking at the immune system and its role in inflammation. We're also going to consider how the immune system interacts with other systems, and in fact all these other ones, but especially the gastrointestinal system and also the stress system. So I've made the point earlier in the course that inflammation is a key mechanism involved in most, if not all, chronic disease, including emotional and neurological disorders like depression and Alzheimer's. So what exactly is inflammation? Well, it's a set of responses to injury and to infection, coordinated by the immune system and designed to counter infection and repair damage. So what's the immune system? Well, we certainly don't need to get too technical here, but you can think of it mainly in terms of the white blood cells, which are in fact found throughout the body, not just in the blood, that carry out the immune system's job of fighting infection and repairing damage, plus also the organs that make white cells, including bone marrow, plus the things that white cells create, such as antibodies. Now, white cells also produce cytokines, which are signaling molecules, just like hormones and neurotransmitters are, and they send messages to other parts of the immune system that control the inflammatory response, either producing more of it or turning it off. And white cells also produce free radicals, which we first met in Unit 1 as the exhaust fumes from the energy production processes. They're highly reactive molecules that can cause damage. And white cells can actually use them to damage, for example, bacteria and other invaders or pathogens, in a kind of localized chemotherapy, if you like. Now, you know about inflammation. If you cut yourself or you sprain your ankle, you get the classic signs of pain, swelling, heat and redness, which feel pretty bad but are actually part of the repair process. But you don't just get inflammation when you hurt yourself. There's in fact always a background level of inflammation going on in the body, and that helps to keep the body in a state of continual repair. So the point is, inflammation is not at all a bad thing, but it can become a bad thing if it runs out of control. So systemic inflammation is inflammation not confined to one place, but spread around multiple systems in the body. And it might not involve pain and swelling, etc. So, for example, you may know that cardiovascular disease involves inflammation of the blood vessels, but you may not be aware of it at all, at least in the early stages. And inflammation especially becomes problematic when it doesn't switch off or when it becomes chronic. You can get inflammation in the brain too, and you definitely don't get any pain there because there are no pain receptors in the brain, but instead you're going to feel it as impaired brain performance, fogginess, poor concentration, fuzzy thinking, disturbed emotions, low mood, fatigue. And as I've said before, brain inflammation plays a role in neurological disorders like Alzheimer's. Now, ordinarily, the immune system, as it is in the body, doesn't have access to the brain tissue because of something called the blood-brain barrier. So this is a special, highly protective system that lines the blood vessels in the brain, and it stops a lot of material that's in the bloodstream from accessing the brain. So for example, white cells, they can ordinarily cross the walls of blood vessels to gain access to the body tissue where they might be needed for repair, but they shouldn't be able to do that in the brain. And the same applies to various substances in the blood that would be toxic in the brain being very sensitive. So the point of the blood-brain barrier is to protect the brain from this kind of toxic exposure. and instead the brain actually has its own immune system in the form of non-neuronal support cells called glial cells, and especially one class called microglia. Glial cells actually outnumber neurons in the brain by about 10 to 1, and they're not just padding, they play important roles, and one of them is to mediate inflammation in the brain. They do communicate with the immune system outside of the brain because cytokines, the signaling molecules, can cross the blood-brain barrier. So inflammation can be communicated to the brain. And it seems that this is significant. Research shows that levels of cytokines correlate with levels of anxiety and depression. And that's at least part of the basis for the theory that inflammation is a key mechanism in brain health problems. The trouble is, once a brain inflammation response has started, it's not that easy to switch it off. So what causes this ongoing inflammation in both brain and body that won't switch off? Well, quite a lot of things actually. We'll start with what I think are the most fundamental factors. So firstly, problems with gut health, raised permeability and dysbiosis, or unhealthy gut microflora, which we talked about in part 6 of the course. And secondly, poor diet, particularly excessive sugar and refined carbs, which, as we saw in part 3, can raise the level of inflammation by causing a form of damage called glycation. And also imbalances in fatty acids, the omega-3 and omega-6 families of fats, which I'm sure you've heard of, and we'll say more about these later on. So gut health and diet, I think, are the big fundamentals in terms of inflammation. But there are other factors too, often related to diet and gut health. Low vitamin D has been shown to correlate with markers of inflammation, and boosting vitamin D levels has a strong anti-inflammatory effect. As we saw earlier in the course, vitamin D works by altering gene expression. And by the way, vitamin D is an important nutrient for gut health. Stress has a bearing on inflammation, and in particular adrenal dysregulation, which we looked at in part 4. Now, it's a complex relationship between stress and inflammation, and I'm not really going to do it justice here, but I will say that inflammation itself puts a strain on the adrenal glands, partly because the hormone cortisol, or at least a derivative of it called cortisone, is key in switching off inflammation. So if you're not producing enough cortisol, then it could be that that's one of the reasons that inflammation isn't switching off. Being overweight is part of the story. Fat tissue, and especially abdominal fat, is not just an inert store of fat, but is metabolically active, and in particular, it's a source of inflammatory signals. Oxidative stress, we met in the last part of the course. It's where your antioxidant defenses aren't coping too well, and it's both an effect of inflammation and a cause of further inflammation. Toxic exposure or increased toxic burden can increase the level of inflammation, and we're all exposed to toxins these days, at least in low levels. And lastly, food intolerance, which we touched on in part 5 on the gut-brain axis, and again it's both cause and effect. There's a sort of a chicken and egg situation going on, so a lot of complexity. Gluten is the most common food intolerance, and there's evidence that it triggers inflammation. And if you have inflammation symptoms, then a gluten-free diet is certainly something to seriously consider. Let's talk about testing for inflammation. First, high sensitivity C-reactive protein. This is a blood biomarker for general or systemic inflammation, and it's widely used by doctors as a marker for disease. But it's also one of those useful markers that reflects the whole spectrum of health functioning from disease through to optimal, so that there's an optimal range for CRP that's really quite different from what doctors are looking for when they're looking for disease. Another set of markers in widespread use is called the lipids panel, and they're connected with cholesterol. Cholesterol isn't directly associated with inflammation, but it is connected, and it deserves some discussion, so we'll come back to this later. Next, fatty acids profile. This test looks at the omega-3s and omega-6s as well as other fats, and it's important to inflammation for reasons that we'll come back to again. And I want to mention one more marker specifically for brain inflammation. It's called quinolinic acid. Now, quinolinic acid is a type of organic acid, so it's part of an organic acids test, which is a urine test. And typically an organic acids test looks at quite a large number of different markers in urine, and quinolinic acid is just one of them. Inflammation is a complex set of responses, so there's no one marker that completely describes the inflammatory response, but quinolinic acid is quite useful as a functional marker for brain inflammation. Quinolinic acid is derived from the amino acid tryptophan, just as the neurotransmitter serotonin is. But in the brain, inflammation shifts the chemical conversion away from serotonin and down this pathway instead, creating more quinolinic acid at the expense of serotonin. So this could be part of the mechanism behind low mood and depression. It could be that inflammation in the brain suppresses serotonin production. So let's go back to cholesterol and to the lipids panel. Now, it's common for a number of different things to be grouped under the general term cholesterol, including HDL and LDL, which are actually structures for transporting cholesterol rather than being themselves forms of cholesterol. And these two are often dubbed good cholesterol and bad cholesterol. HDL is said to be good cholesterol because it correlates to cardiovascular health, while LDL is found in arterial plaques and superficially correlates to cardiovascular disease. Actually, the truth is more complex, but before we get to that, I want to mention one more marker, triglycerides. Triglyceride is a form of fat, and high levels in the blood correlate to atherosclerosis, which is a hardening of blood vessels and associated with cardiovascular disease. So it's a useful marker, but triglycerides are not directly a sign of inflammation, but in fact high levels are actually caused by high sugar and carbohydrate intake and insulin resistance. Now I'd like to recommend this book, Grain Brain, by Dr. David Perlmutter, who's an American neurologist. He talks a lot about gluten and its connections to brain health problems, and it's certainly worth a read for that alone, but I mention it here because he discusses cholesterol in light of research and reports some rather surprising facts. Cholesterol has a bad reputation in popular consciousness, which is unfortunate because the truth is that cholesterol plays some vital roles in the body. For example, it's the starting point for the production of a number of hormones, including a lot of the adrenal hormones that we touched on in part 4 of the course, and also including vitamin D, which is of course mainly made in the skin in the presence of sunlight. In fact, the body will produce its own cholesterol. What it doesn't get in diet, it makes. Now that alone suggests it doesn't make much sense to avoid dietary sources of cholesterol such as eggs, but all the more so when you consider that some important pieces of research actually show that total cholesterol, far from indicating illness, actually correlate positively with health. And more than that, cholesterol deficiency can actually be a genuine problem. In fact, symptoms associated with cholesterol deficiency include some of the very things that we're most interested in: anxiety, depression, and brain fog. Even LDL, the so-called bad cholesterol, turns out to be far from the enemy you might have thought it was. The body makes LDL because it serves a role, and that is to transport cholesterol into cells. And that's something that's particularly important in the brain, and if you didn't have enough LDL, then your cells would suffer for the lack of cholesterol. So why is it that LDL apparently correlates with cardiovascular disease? Well, it turns out that the real risk factors are a subset of LDL, specifically small particle size LDL. This has been found to correlate with heart disease, and secondly, oxidized LDL, or LDL that's been damaged by the chemical process of oxidation, which is in turn linked to free radicals, those damaging molecules we met earlier in the course. So the real culprit is oxidative stress. Earlier I said that the fatty acid groups omega-3 and omega-6 have a bearing on inflammation, so I want to go back and explain why that should be and why it's useful to test for them. These unsaturated fats are essential to health in a number of ways. Most notably, they're raw materials for building cell membranes. That's important in the brain because the shape of cells means that you have a lot of cell membrane in the brain. Now, if you don't have enough of the best quality fats, the body has to use whatever it can, that is inferior materials, but the price of that is inferior function. Omega-3s and 6s are also important in building receptors for neurotransmitters. So all in all, it's not surprising that omega-3 and 6 deficiency has been consistently linked to brain disorders, anxiety, depression, brain fog, and even insulin resistance. What's the connection between these fats and inflammation? Well, another of their roles is that they can be made into prostaglandins, which, like the cytokines we've already mentioned, are signaling molecules used by the immune system. And there are a number of different prostaglandins, some of which signal more inflammation, while others damp down inflammation. It turns out that the omega-3 fats, and especially DHA and EPA, are anti-inflammatory because they make anti-inflammatory prostaglandins, while one particular omega-6 fat, called arachidonic acid, is pro-inflammatory because it's the precursor of a pro-inflammatory prostaglandin. That's not to say that arachidonic acid is bad, because in fact it has essential functions, but what matters the most is the balance between the two groups. So when you test for omega-3 and 6 fatty acids, firstly, you want enough of both, but you also want relatively more of omega-3s in relation to omega-6s, otherwise you have a tendency to inflammation. But the problem is that the typical modern unhealthy diet contains a lot more of omega-6s than 3s, mainly because of the predominance of cooking oils like sunflower oil, which are heavily weighted towards omega-6s. Now, just one more point needs to be made here, as if the picture weren't complex enough. We need to bear in mind that while in general many of these fatty acids are good, ones that have become oxidized are not. They're toxic and pro-inflammatory. Even omega-3s, if they're oxidized, they're harmful. And the unsaturated fats are in their nature prone to oxidation, especially when heated. That's why it's a bad idea to cook with oils such as sunflower oil that contain a lot of them. It's much better to cook with saturated fats, and also olive oil, which are more stable. Now, a fatty acid profile will look at other forms of fat besides the omega-3s and 6s, including saturated fats, which were once thought to be dangerous for cardiovascular health, but more recent research evidence has cast a lot of doubt over that. Some saturated fats are even found to be particularly useful. What matters is the length of the fat molecule, so a fat is composed of a chain of carbon atoms surrounded by hydrogens, and the short and medium length fats have been found to be quite healthy, good for gut health, and they may also help to promote fat burning, so may be useful for weight loss, while the long chain fats are not so useful. You've also got omega-9 fats, which on the whole are healthful, and olive oil is the best known source. But the real bad fat is trans fat, which is manufactured fat. It's found in hydrogenated oils. It doesn't exist in nature and has been found to be actively harmful, and is banned in some countries. Let's conclude by summarizing what we've covered in this presentation. Inflammation is a healing and repair response. On the whole, a good thing, but chronic inflammation, or inflammation that doesn't switch off, is associated with chronic illness, including many brain disorders. There are many possible causes of chronic inflammation. The key things are probably gut health problems such as infections and also poor diet. But chronic inflammation can also be related to failures in signaling, whereby the normal mechanism for switching off inflammation isn't working, perhaps due to stress. Cholesterol is not the public enemy you might think it is. In fact, it's essential to brain health. Throughout the course, we've been emphasizing how functional testing is useful because it identifies opportunities for targeted interventions that make the most difference. And while looking at markers for inflammation is useful, it may be even more important to look at the causes of inflammation, such as gut health issues, fatty acid status, and in particular omega-3 to 6 balance, and vitamin D, which is strongly anti-inflammatory.